Hello everyone, today I'm going to go through some moles and gas laws problems. The problem is Na2CO3 and HCl react at the following reaction, that we have the balance equation here, and they ask us to calculate the volume of 0.2 mole per liter HCl needed to react with 9 gram of Na2CO3. So we have a solution of HCl and we have solid Na2CO3, and we want to find volume of HCl that we need to react with that. So to summarize what we are expected to find, so it means that I have gram of Na2CO3, and something that I want to find is volume of HCl. So when I have gram of Na2CO3 and I want to find volume of different substance, the only thing that we can just link two different substances is through their number of moles. So the first thing I need to find number of mole of Na2CO3, then using balance equation finding number of mole of HCl, and from mole of HCl I might be able to find volume of HCl. Let's see how we can do it. From gram of Na2CO3 to mole of Na2CO3, the formula that we need to use, N equal M divided by M. Mole of Na2CO3 to mole of HCl, we need to use ratio imbalance equation. And from mole of HCl to volume of HCl, we know it's a solution and we have molarity of HCl in the equation. So we need to use the formula for molarity, number of mole divided by volume. Okay, so we started first step. We know molar mass of Na2CO3 is equal to 105.9888 gram per mole. You can calculate this one. So as a result, number of mole of that using this formula is equal its mass that in the question is given to us, 9 gram, divided by its molar mass, that it's equal to 0.08491 mole Na2CO3. So right now we've done step 1. Step 2 is finding mole of HCl using coefficient imbalance equation. So something that I need to do now, I write Na2CO3 because I have the number of mole for that. It's ratio with HCl. As you can see in balance equation, the ratio is 1 to, let's see if we balance this one should be 2 to be balanced. So the ratio is 1 to 2. So right now, if we have 0.08491 mole of Na2CO3, the number of mole of HCl X equal 2 times 0.08491. That should be equal to 0.1698 mole HCl. Right now we are in this part, we have mole of HCl and we have molarity in this question. That molarity was equal to, the question is given to us, molarity of HCl is dot of our question is equal 0.2 mole per liter. So just I substitute the number in the formula, NV, number of mole, and I can find the volume that is equal to 0.849 liter, or I can say 849 milliliter. This one was step 1. Right now we go to step 2. Step 2 or part B, calculate the volume of CO2 produced at STP. Okay, so we are looking for volume of CO2. Just to balance this one, I'll put the 2 again here, at STP condition. So let's see what we can do. Firstly, you need to remember when we say STP, it means that pressure is 100 kilopascal, temperature is 73.15 Kelvin, and then at this situation, 1 mole of any gas has the volume of 22.71 liter. Okay, right now what we have here, we calculated number of mole of Na2CO3 in previous question. So I have mole of Na2CO3 and I want to find volume of CO2. From mole of this to volume of this one, definitely the first step is I need to find number of mole of CO2. How I can do it? Using balance equation, coefficient in balance equation. So I use ratio. And then from this small to V, I can use this formula. That is number of mole equal volume of gas divided by volume of 1 mole gas. Right now, so I go first step. I have number of mole of Na2CO3 that we calculated in first step part A, that it was equal to 0.08491 mole. Right now, because I want to find number of mole of CO2, I write Na2CO3 to CO2 is equal, ratio is 1 to 1. So if I have 0.0849 mole of Na2CO3, so it means I have same number of mole of CO2. Okay. Right now I have number of mole of CO2, and because the condition is STP, I know Vm in this condition is equal to 22.71 liter, and I have the number of mole. So just I substitute number in this, so it's 0.08491 equal V 22.71. As a result, V equal to 1.93 liter of CO2 at this condition, that is STP. Right now, part C, calculate the volume of CO2 produced in 2 atmosphere and 100 degrees Celsius. So this time we want to find volume of CO2, but the condition is not STP. Pressure is 2 atmosphere and temperature is 100 degrees Celsius. So something that we need to do, again, we say, okay, we have number of mole of CO2, just we calculated that in step 2, that was equal 1.93 liter of CO2. This is number of, oh, no, this one is volume, sorry. The volume of CO2 that we calculated was equal 0.08491 mole of CO2. Right now, condition that we have, P equal, we have 2 atmosphere, and then temperature that we have is 100 degrees Celsius. So we need to use formula PV equal nRT. But we remember in this formula P should be kilopascal, V liter, N definite number of mole, T should be Kelvin, and R is equal 8.314 joule mole Kelvin. So first thing is I need to convert atmosphere to kilopascal. So I know 1 atmosphere is equal 101.3 kilopascal. As a result, P is 2 times 101.3, that is equal to 202.6 kilopascal. And also I need to convert temperature to Kelvin. We know T Kelvin is equal T degrees Celsius plus 273.15. So 100 plus this is 15 Kelvin. Right now, and also we have the number of mole as we calculated in part B. The only thing that right now we need to do, just substituting number here. So P equal, just I substitute here. So P equal 2.2.6. V is something that I want to calculate. Number of mole is 0.08491. And then R, just we have it, 8.3, and temperature is 15. As a result, V equal 8491 times 8.314 is 3.15 divided by 202.6. That is equal to 1.30 liter of CO2 at this condition. I hope it helped.